On the sun-scorched plains of South Texas where the heat shimmers and the horizon stretches endlessly, a new chapter in space exploration was being written. This is where dreams take flight, where the boundaries of what's possible are constantly being redefined. Starship stood gleaming, a colossal stainless steel monument to human ingenuity. It was more than just a rocket, it was a symbol of humanity's boldest dreams, a testament to our relentless pursuit of the stars. The air crackled with anticipation as the countdown ticked away, but that anticipation soon turned to shock. Suddenly, a violent explosion tore through the upper stage with devastating force, sending twisted metal raining down on Starbase, a stark reminder of the risks inherent in pushing the boundaries of aerospace technology. The test flight was lost in a fireball, a dramatic and unexpected end to what had promised to be a monumental leap forward. It was a dramatic failure witnessed worldwide, a spectacle of both awe and disappointment. This wasn't just another rocket mishap. It was a setback that reverberated through the entire space community. It was a major challenge for SpaceX, and its ambitious vision of reaching the Moon and Mars, a stark reminder of the difficulties that lie ahead. Immediately, engineers rushed in, gathering data from every sensor and camera, meticulously piecing together the puzzle of what went wrong. They were searching for answers in the wreckage, sifting through the debris to understand the root cause of the failure. Was it a faulty valve, a critical component that failed under immense pressure? Or was it a structural flaw, a weakness in the design that buckled under the stress of launch? Or something else entirely, a hidden variable that had eluded their rigorous testing? Each clue would shape the next attempt, informing the design and operation of future starships. For SpaceX, this was a costly but invaluable lesson. One paid for in steel and ambition, a reminder that progress often comes at a price. Setbacks like this test resolve, pushing teams to their limits and demanding unwavering dedication. They inevitably push timelines, but they're part of the journey, an integral aspect of innovation and discovery. To understand why this matters, why this failure is more than just a news headline, we must look beyond the flames to what Starship truly represents. A bold step towards a future where humanity is a multiplanetary species. Starship isn't just another rocket, it represents a paradigm shift in space travel. Another rocket confined to the limitations of single-use systems. It's a fully reusable system, designed from the ground up to be flown and reflown, drastically reducing the cost of access to space. This is a game-changer, designed to make life, not just visit, multiplanetary. It's about establishing a permanent presence beyond Earth. With two massive stages, the Super Heavy booster and the Starship spacecraft itself, Super Heavy, providing the initial thrust to escape Earth's gravity, and Starship, the versatile upper stage capable of carrying both crew and cargo, it can lift over, a truly staggering amount, 100 tons, to low Earth orbit. And up to, an unprecedented number, 100 people, on long-duration missions, then return for, after delivering its payload, another flight. This rapid reusability is key. This reusability could dramatically reduce, launch costs by, an incredible amount, orders of magnitude, opening up possibilities previously deemed impossible. Making ambitious missions like establishing a base on the Moon or sending humans to Mars possible. It's a new era of space exploration. NASA has chosen Starship, recognizing its potential to land astronauts, the next generation of explorers, on the Moon, marking a significant milestone. Under Artemis, the program to return humans to the lunar surface, tying its success in many ways to America's lunar return. The stakes are high. Delays here ripple through, impacting NASA's plans for lunar exploration and beyond, and humanity's next steps as a spacefaring civilization beyond Earth. The future is unwritten, but Starship's ultimate goal, its grand vision, is Mars, the red planet. Its design aims to carry, in a single launch, everything needed, all the essential equipment and supplies to build a city, a self-sustaining settlement on another world. A truly audacious goal. Every test pushing the boundaries of engineering, every explosion, while seemingly a setback, carries the weight, the hopes and dreams of our future in space. It's a long and challenging road. That's why each setback, each anomaly, is so significant. It's a reminder of the difficulty of spaceflight. Starship's development has been a public saga of trial and error. SpaceX's philosophy: build, fly, fail, fix, and repeat, learning from every attempt. Early prototypes like SN8 to SN11 soared, belly-flopped, and exploded, each failure yielding crucial data. SN15 finally stuck the landing, proving progress. Full-stack tests followed with each flight pushing closer to orbit despite setbacks. The most recent flights have shown real progress with controlled splashdowns and improved performance. Every explosion is a step forward, not a sign of doom. The path to orbit is paved with lessons learned in fire and steel. In the complex world of rocketry, where pushing boundaries is the norm, failure isn't defeat, it's not the end of the road, it's a teacher, offering invaluable lessons. Each Starship explosion, while visually dramatic, is a data-rich event, a treasure trove of information revealing flaws, sometimes subtle, sometimes glaring, that even the most sophisticated simulations can't predict. Thousands of sensors embedded throughout the rocket capture every moment, every fluctuation, every anomaly, helping engineers with their analytical prowess pinpoint weaknesses, identify critical failure points, and improve the design, refining it for the next iteration. SpaceX's rapid iterative approach, hardware-rich approach, building and testing quickly, means learning faster, accelerating the pace of innovation, even if it means accepting the risk, more public failures. These early explosions, these fiery trials, buy down risk, reduce the chances of catastrophic events for future missions, paving the way for safer journeys, especially those carrying crew. The disappointment is real, the weight of the setback is felt, but so is the determination, the unwavering resolve to solve the next puzzle. Wreckage is analyzed piece by piece, data scrutinized, every line of code, every sensor reading, and the next prototype, the next iteration, is made stronger. Progress is a series of, sometimes dramatic, leaps and stumbles, inevitable setbacks, not a smooth climb. The courage to risk failure, to push the limits, is what drives innovation. Each explosion, each fiery event is the start of a new chapter, a chance to learn and rebuild, not the end of the story. This setback means delays, investigations, redesigns, and a pause in the rapid test cadence. NASA's Artemis program feels the pressure as Starship is critical to landing astronauts on the moon. But SpaceX's resilience is legendary. New prototypes are already in the works, ready to fly again. Rapid iteration is their strength. Each failure is a problem to solve, not a reason to stop. The journey to orbit continues undeterred by setbacks. Space exploration is a race between ambition and physics, and the world is watching. Starship is more than metal, it's a symbol of our drive to explore and push boundaries. From the Texas launch pad, the dream of reaching the moon and Mars lives on one explosive lesson at a time.